My name is Jean Carriere. I'm here to talk about something a little bit different than BIM, but mainly we're doing an integration into BIM to bridge the performance gap into energy modeling. So it's more of an application of BIM, but very, very specific. So we're not going to talk big picture. We're going to get really down and narrow with our topic. So anyways, I'm really happy to be here because I think I was here, I think it was maybe 4 years ago, 4 AGMs ago, where I spoke in Ottawa. And that was kind of where I was with the technology 4 years ago. So it's kind of gone full life cycle. I'm here again, talking about a little more advanced topic than I did 4 years ago, but here it is. There you go. All right, so the learning objectives that I want to talk about, just to kind of set the stage, we're going to talk about interoperability with building energy modeling. We're going to talk about exchanging data between both platforms. But again, we're going to be talking about BIM and building energy modeling, two different subjects. We're going to fuse these two together, and we're going to start to interoperate between the two. We're going to integrate architectural data into your models. We're going to reintegrate. We're going to do iterative design. It's really leveraging the power of BIM using other software. And finally, we're just going to define those information exchanges, because the idea is that if I can take your model, your BIM model, in your BIM project, and I can take all the information, your assemblies, your loads information, I can grab all that and I can simulate it and give it back to you in a simulated environment. That's the idea behind what we're going to do today. So I've got 3 stages of integration. So I call them stages because we have, you guys, we have the topic of level 1, 2, and 3 in BIM. So I'm going to say stage 1, 2, and 3 because it's synonymous, but I am also not talking directly about level 2 BIM as it's coined the term. But it works hand in hand. So back then, 4 years ago, I talked about the BIM integration, which was the first concept, the first stage. I was able to integrate your model into our energy analysis software, and that worked just fine. So I got a lot of productivity savings. It was great. But next, we started to, once we have that integration, we can start moving information across between the two. And so that's what I call the stage 2, which is synonymous with your level 2 BIM of data interoperability. So the last stage is the level 3, is asset management. So you want to start to operate these buildings and these building assets. So we're doing enhanced commissioning, calibration, model-based verification. So this is really bridging that gap between the proposed and the actual happening. So those are my 3 stages. So the presentation is going to go in 3 different tiers. I'll kind of build it up, and we'll finish off at the end with the asset management. So I'm sure you all have seen this kind of typical graph of data basically exponentially increasing over time. So it starts off, the building is very schematic, it's very, this is a program, there's not really much going on, and so we want to do analysis at this stage, but we want to keep it very, very simple. As you get more and more information, we're dealing with gigabytes of data that are happening, that are moving through your models, and then we're iterating gigabytes and gigabytes of data. So we're seeing that kind of go up. Once the building starts to get operated, we have metered data points, and then we have 10 meters that are operating at 15-minute time steps times 24 hours times 365 days. We have thousands and thousands and hundreds of thousands of data points. So the data just really continues to grow and grow at every life cycle. So it's a matter of connecting that information all the way through and understanding how to leverage it all the way through to the end. All right, so basically, the first stage, we have the BIM integration. So it's nice and simple, but basically the integration takes a little bit of processing work. So you guys are all very familiar with designing for coordination, which is great. I used to teach Revit, I used to teach coordination, but the models that we use are full volumetric models. They're complete volumes, but they are not coordinated models. They're very, very simple. So in those terms, we integrate a level 150 model. And so what we do as for coordination, we do typically somewhere around level 300 or 300 and plus, which is over-detailed. It's actually too much detail. So the idea is that there's 2 ways of integrating BIM into your energy analysis software. Either you build it from level of detail 0 and you go up to 150 in a simplistic way, and then you continue to see that model off, or you go the other way, which is the way that the industry has been reacting a lot more, is that you guys just keep doing what you're doing, you give me the model and I'll help you fix it. So it takes a little bit of fixing, a little bit of processing work, but I have to go from level 300 down to 150. And I got to do that in a way that doesn't compromise your model, but captures the essence of what is actually there. But the idea is that if you've got 500,000 square feet of building, in a few hours, I can get that entire model integrated into our energy analysis software. I can start running loads with a few more hours, and I can give it back to you. And I can exchange all that information back through your model. So it's, again, requires a little bit of work, a little bit of training, but I'm sure we're all used to a little bit of training and knowing how to apply our tools in the right way. But again, it's not so much of an export the GBXML file into our software, because that's not going to work at the first shot. It takes a little bit of time. But that's the idea. So once you get the model integrated, you have the link. I call it the BIM integration link. So now I've got the model working. I'm synchronized with your work and my work. Now we can start doing optimization. So that the idea behind it is that we can run a first simulation. We can figure out where the building's at, how much your load is, what your envelope looks like. Is it good or is it bad? And at that point, the first simulation is designed to define where you're going to be. Is that where you want to take your building in the future? And a lot of the times, we're doing code compliance work. We're seeing where you're going to end up for your lead credits, and we're doing that really, really early. If you're not satisfied with 5% above code just to get your building permit, and you actually want to maybe reduce your window-wall ratio or increase your envelope and see what's going on. So the idea with energy modeling, and that's kind of been typical with industries, a lot of people use it just for code compliance, which, yes, you have to do it for code compliance. If you hadn't known already, you must submit a model. But doing it at the end isn't really going to help you. So, and when you do it at the end and you call me at the end, there's not really much I can do to help you. So the idea is to do whatever we're supposed to do at the beginning and actually inform design and actually control and influence where the design is going to go. So, it's really natural to have this process to be iterative. And again, when we're talking a large scale, P3 project that's moving at a 2-week schedule, where a lot of things change, and they should change. And when I do my feedback, I actually expect change. So by expecting this change, I want to reintegrate that information back in. So it's an open loop. And then the idea is that when there is a change, I reintegrate that information, I compare my results, and I send it back to you, and then we see, did that improve? Did I make something better? And then if so, if it did get better, then let's kind of optimize it. Let's look at all of our options. Let's see multiple envelopes. Let's take the glass properties. Let's keep changing your shading coefficients, all that kind of stuff. So we just keep going and going and going until you have a really awesome building. So take a little sidestep. How this really works. So we have a BIM Integration Techniques. So the techniques is something that I've been teaching for years, ever since I started doing it 4 years ago. We teach it at schools, at Algonquin, at George Brown. I teach it online. I mean, it's not a mystery. It's something that can be learned, can be taught. It's very simple. And actually, it's actually much more simple than the way that you guys design. Because it's a level of detail 150, it's actually supposed to be simple. So the idea behind it is that we draw according to our center lines. We draw very simple, thin modeling walls. Very, very precise, a little too precise, kind of AutoCAD precise. Everything's got to snap together. There is no look and feel, because what we're doing is we're exporting a file, a GBXML file. And that file doesn't really care how it looks. It actually just cares how things are snapping together, how thick the envelope is. It's just looking for the analytical perspective of your rooms. So if your room doesn't go all the way up, then it'll recognize that, and it won't actually export the right amount. So everything needs to be complete. Imagine filling up your building with water, and the entire building would be full, and there is no leaks, so nothing's going to spew out. So if you've got these weird little bulkheads, that the water is going to go out through those bulkheads. So what I usually do is I delete them, turn them off, say non-room bounding. Your structural columns, again, spaces, we're going to go around that. So that's kind of the idea. I follow a hierarchy just to kind of top things off. So, so when I follow this hierarchy, I go from the shell to the core to the interior. When you follow this, then it makes it easy for me to, I teach this course online, and I have somebody from Germany send me their model. I know exactly how they did it, why they did it, and how they deviated from the process. So I can fix it in a matter of a few minutes, and I can go into a large-scale hospital and actually see, oh, you messed that up, let me fix it. So following these rules is something that I teach the 5 modeling techniques, as in that's all you need to know. It's not the typical what not to do, because we've got a lot of user guides on these things that, don't do this, don't do that, don't do this, which is hard to learn something when you're being taught what not to do. What should you do? And so that's kind of, I'm a different approach type of guy, but I teach people on what to do and how to pull it off. So if you follow this, it'll work. But so on that, so basically what I've been doing is that the approach that I've taken is a simplistic approach from level detail 0 to 150. I've been doing a lot of work right now with detailed models, adapting existing models, and there's a lot of ongoing research going on. So that it's much more complex to do the existing model. And again, we're asking for a very complex model where we cannot compromise the integrity of it. So that's kind of, I have a lot more content coming out, I guess, coming up. But the idea is that once the integration is linked, you can leverage a lot of these features. So these are some of our import features. Obviously, the building geometry, you get the whole thing. So if you're used to building an energy model, or if you're familiar with energy modeling, either way, it's either you do the import feature and you leverage all this capacity, or you build it from scratch in a software that is either two-dimensional or very, very bad at actually creating spaces. If you're familiar with EE4 or eQuest, not that they're bad software, but they're very rudimentary, very simplistic. They're very non-Revit native. So it's just a different way of modeling. So what we do here is we bring the whole building geometry. We build construction types. So if you have a dozen or 20 wall types, they're all going to be assigned at the right spot. We bring all the materials in those wall types. So if you have 20 materials and 20 wall types, you just brought all those in. Your space types, your space type information, everything associated with those space types, your building loads, lighting density, occupant density, all that information. So you can have thousands of spaces. You can bring all that stuff in. If you don't create the integration feature, then all that stuff needs to get built up anyways. So might as well leverage the capacity of BIM to leverage all that stuff that's coming in. So it's really just a great opportunity to bring all that in. So that leads to the next stage, the data interoperability stage. So I'm going to have a quote from the UK's Level 2 BIM initiative, because well, our company IES is from the UK. There's a lot of drivers going out from internationally. So I'll read from that. But basically, you guys are familiar with it. It's a single environment to store shared asset data. So the idea is that when you guys run your BIM project, you get the architect, you get the MEP modeling in it, you run an energy model, it's usually disconnected. And so the idea behind this is that I can actually bring this entire model into your BIM project so that the loads that you're using to size and design your systems is the ones that have been simulated. And they've been simulated with an energy modeling software that is accounting for surface temperatures and all kinds of stuff. So it's validating the information and making that information accessible to everyone, so that when the architect is not typically the guy that looks at the loads, when he sees the conference room, your loads are through the roof, and he's got a big VAV box, and there's no room for that box. It's too big. Well, maybe you got to change the lights. Maybe you got to change the windows. Maybe you got to start shading. Maybe you got to do something about cutting the load down in order to redesign that space. But it's giving the designers and the people access to the information that's typically stored on a spreadsheet somewhere else. So it's connecting all that stuff, and it's bringing that through that giant database we call BIM. And it's locating the right information at the right spot so that the people can make the right decision. So the idea behind interoperability is that I got this little funky graph going on where we typically start off your design in schematic, and then we define the building, we do an integration, and then at that point we just define our building loads. So at that point, we've done a level 1 integration. The next stage is that we can integrate that stuff with your BIM project, and then we can start to size our systems. So those systems, again, we can loop that information back into your MEP project, and we can keep that loop going. So once we create an open loop, we can keep iterating. So but the idea is that once we're moving to the next stage of asset management, the next step is to start to incorporate our sensors, our metered data. And so we start to specify the equipment, and that equipment is specified based on our loads and our sizing. Once we specify it, we want to know how it operates. We want to know if it's operating the way it should. Are our set points the way that they should be? How is the impact on the occupant load, the lighting load? And so we start to reincorporate that information, synchronize it, and create a calibrated model. So then we can do model-based commissioning and all kinds of stuff. So that's kind of the workflow where we're going. But the idea behind at this stage when we're finishing off, putting basically our compliant energy model information into the BIM project, we're creating an energy view. So I'm actually on the Building Smart Canada technical board. So I'm working with them and trying to see where this is going and work with our governments, work with the people, and what kind of information do they want? Because you're mandating energy modeling, and you should be mandating BIM projects, at least maybe not here in Canada, but somewhere they are. So it's just a matter of stuffing that information into your project and seeing it through to their asset managements and their BMS systems. So basically, as per defined by Building Smart, the energy view, simulation view, serves a specific purpose of capturing information from buildings to calculate energy usage and derive energy ratings. So it's just basically saying that this model, this information leads to this energy. It's kind of a snapshot in time. And in the end, you can use this more for energy auditing, but it's more of a compliance stage model. So, and then we get to stage 3, the asset management. So again, as per the Digital Build Britain, the ability to bring together through open data standards from design, construction, and operations, offering the ability to analyze and create the learning feedback loops to deliver sustainable, long-term improvements in asset performance. So it's really just connecting all this stuff and actually leveraging what is actually happening in the real-world data, bringing it into our software and actually using the software to make informed decisions about whatever is going on. Maybe you got a heat wave coming up. Maybe climate change is happening. Maybe you want to know, what if the temperature goes up 2 degrees? Is my coils going to be able to keep up? Things like that. So, what if I get 200 people in this room and it's too hot? Is my system going to be able to keep up? So it's really throwing a curveball to your building, but actually doing it in a simulated world. So the operational data, what is it? How much of it do we have? We're talking about weather sensors, chiller performance, occupant sensors, you name it, whatever we can sense. We have buildings that, now our typical building, we have 40, 30 sensors, maybe up to 100 sensors. So that's a lot of stuff, a lot of information we're sensing, but we're just literally sensing them and just putting in a BMS and hoping that it just works itself out, hoping that your spec drawings were 100% accurate and that the environment will just suit itself. So we're bringing in sensors, and we're using this stuff to, what we're going to call is bridging the performance gap. So we're going to go from a compliance model, the model that we've done for lead compliance or code compliance, which is just based on assumptions. We're just saying, the building's going to be operated from 8 to 5, which is good enough. But maybe we showed up here at 6 in the morning. Might be a little bit different. So that's where our proposed is usually an assumption, and it's never going to be accurate. It's always going to be 5–10% off because inherently it's supposed to be. So what we're going to do is we're going to bridge that performance gap, and we're going to actually bring our operational profile into our simulation, and we're actually going to get a much closer, 5–10% closer. We're going to be able to save maybe another 5–10% energy by just tuning and actually understanding how the building works. So this building calibration process is done really, really easy with our software. So we actually synchronize the meters with our software through a cloud. And so every time we log in, we can see exactly how it's performing. We can swap out weather files. We can see how the weather is actually happening. There's lots of really cool stuff that we can do. And it's really easy to understand how the building works from our software interface, as opposed to kind of walking into it and just seeing how it should operate. So there's different levels of calibration. Again, any data is good data, but the more data that you have, the easier it gets. So either you're just doing your end use occupancies, either you're doing lighting or just all kinds of heat gain. Whatever you've got, you can just keep improving your calibration process. So you can do your HVAC systems, your chillers, whatever it is. So if you can see your chiller is turning on or spiking at a certain time, you might want to know why. Why is it spiking? Maybe somebody comes in at 5 o'clock and opens the windows. I don't know. But you got to figure that out. But what's actually happening is that it's spiking and it's using a bunch of energy. So you should probably get to the bottom of it. So basically how it looks like is that we have, right here we have these kind of charts. So the top one is a lighting profile. And in the blue is what we use in our compliance model. We use kind of an 8 to 5 on and off, on and off, on and off. And it's very, I don't know, square, which is not how life is. Life is not square. Life is actual turning on and off, on and off, on and off, just on a minute-by-minute basis. So what we do is we bring in, we convert those metered profiles into free-form profiles, and we bring those back into the simulation. And what we've estimated is we've reduced our lighting load by 30%. We've also reduced our equipment load. So the equipment is basically, we have this much energy using all the time, which is not really the case. Your computers go on and off. So we have a 62% load reduction in equipment. So what does that mean? That means we have a lot less heating energy being generated in your building. So when you have a lot less heat, what's going to happen to your boilers? So their boilers are saying, okay, well, it's not as hot. We don't have as much free heat. So I need to generate more heat, more boiler energy. Your cooling load, your chiller is now oversized. You have more chiller capacity than you need because you have less heat. So stuff like that is just, you're designing a system and it's not tuned to the actual operations. So when you have this information, you're able to really see how it's going to perform in the real world. And that's kind of what the whole point of it is, that we do our best, we design our systems, and then we want to learn from how they're actually going to operate in a real world. So some of our asset management applications. We have a few applications, either to undertake post-occupancy evaluation. So after your occupants come into the building and use it, you could keep doing analysis at that stage. We could do the lead version for is monitoring-based commissioning. We can use existing operational data for similar properties. So a lot of stores, retail stores, they're using multiple stores. They want to actually see if something works somewhere, they're going to continue using it everywhere. And then finally, retrofits. So if you have a building, we can go and actually see how it's actually working in a way of not just interrogating an Excel spreadsheet, but actually learning from the real world and seeing the actual impacts. So in conclusion, we can use the BIM execution plan and as part of a planning document to say how we're going to actually incorporate life cycle building energy modeling, not just at the end for code compliance, but throughout the entire process. How are we doing our loads? How are we doing our system sizing? How are we actually verifying everything that we're doing all the way through to the end? And that's kind of what my role has been doing in being kind of the BIM expert in the energy modeling sector, is really helping teams specify those requirements at every stage. If you want to do natural ventilation, great, I support you, but we need to know about your windows, your crack openings. We need to know what's happening at the beginning, and then we need to verify that all the way through to make sure you're actually performing the way you should. Because when you change your window-wall ratio, when you change something, everything changes. When your load changes, your systems change. And then we can also start to explore the hidden values in the building management systems, in line with the implementation of implementation plan. We can also do plan preventative maintenance. So if you know that your set points are, when it goes to a certain temperature, something happens. So you can start to trigger these settings. And then finally, you can do a post-occupancy evaluation. So you can see exactly how it works. And that's the idea, is we want to start to push the energy model a little bit past your code compliance into, I'd say, enhanced commissioning. So you can actually commission using model-based commissioning. And so that's kind of the next stage where we're trying to push into. We've had a lot of success in the UK, and I'm just like to bring the idea over here in Canada and see what you guys think, and if we can roll this out in Canada and have another case study up here maybe in the BIM Awards next year. So anyways, that's it for me. So thanks, and I think I'm all out of time, but if you have any questions, we've got a booth out here, so please come by and say hi. Thanks.